Hi everyone, I'm Rebecca. For those of you who don't know me, I'm the secretary of our EV group. So I'd like to welcome, there's a few new faces I think, a few who we haven't seen for a while and a few regulars. So thanks all for coming along tonight. I'm really excited about tonight's topic. So I'm actually stepping in Dean's place, who couldn't make it tonight. So Dean's our facilitator or convener of our group, and as he's not here, I'm stepping into his role, so excuse me if I miss anything. But there's just a few things we usually cover just before we get into the main presentation. So usually that's pretty much open to the floor. The first part of what we usually discuss is anything in the EV space that is happening, has happened. Evening, Bryce. Has happened or is going to happen in the near future in the EV space. So is anyone aware of any events that have been going on? Anyone been showing off their vehicles recently? Yeah, I saw a few hands go up briefly. Anyone want to mention what's... No?
I've got a leakage problem with the DC-DC converter.
Oh.
12-volt battery. If you don't use the car.
That might be in the garages section even, actually, where we can talk specifically about what's happening with your vehicles, I think, because they're the two categories I've got. So has there been any, is anyone's council promoting EVs or, hello? Or,
I think I saw it on the news today. The news tonight before I came, they were talking about Melbourne's road structure and making it more bike friendly.
great.
So that's not quite EV, but EV always bikes.
Well, yeah, I think that's a major barrier for people jumping on electric bikes is the road safety issue of bikes generally. So, yeah, I think that that counts, definitely.
Yeah.
Yeah, I saw something on the web about bike lanes in the city too. So, yeah, I mean, just for those of you who don't know, we don't discriminate between cars and bikes or trikes or couches or whatever electric vehicle you may have. So yeah, is there any events or opportunities for us to show off?
Rebecca, I don't know. I didn't take a note of when this was. I suspect it was since the last meeting that Queensland has legalised the use of segways in open space.
Really?
Yeah.
Fantastic.
Yeah, I haven't checked out the details, but yeah. But
on that note, I actually saw a Segway with a disabled sticker on it going through my local shopping centre the other week.
okay.
Yeah, so there may actually be a clause for you to be allowed to use vehicles like that if you've got a disability exemption or some such thing.
I think in Victoria there is. You have to have written notification from your doctor, but this was for general public.
Yeah, right.
Use.
Fantastic.
My understanding is it needs checking up though.
Okay.
Yeah.
Yeah, great. Everyone knows Segways? Yeah. Excellent. Cool. Are there any events upcoming that we should look forward to and try and book in our diaries for attending and showing off our EVs at? Bryce?
When's the next EV
Bryce is already hanging out for our next EV Expo. Awesome. I think the plan for the next one is to do what the original plan was for this one, which was to affiliate it with the Sustainable Living Festival. So hopefully we'll be able to get a bit more exposure through the SLF and that sort of thing and have it tied to that event. The SLF is actually for a couple of weeks, the period of the whole festival, and then there's a big weekend at Fed Square, so we obviously try not to clash with that, I suppose, but yeah, hopefully tying it in with that event and getting some broader promotion. So yeah, next February we'd be aiming for to have our... Can I get a show of hands who was at our EV Expo? Awesome, so a bit more than half of the folks here were there. That's great. Did everyone have fun?
Yeah, it was good.
Yeah, excellent. We've got some things to work on for next time to improve it, so that's always a good thing. So yeah, it's thank you for all those who came, especially for all those who helped. So yeah, well, if there's no other events on the horizon that anyone can think of. The only other thing I know of is that King Lake drive is still pending, but I'm really not sure how they're going to sort out the charging of vehicles once all the cars get to King Lake.
I have an idea. We might be able to use that pub assist trailer.
Yeah,
Borrow that because that's a mobile generator.
that was a great thing. How many vehicles can that charge in?
Two.
Two at once, or?
Yeah.
Okay, yeah, that's a great
And
start.
that's- Yeah, it's rated at 32 amps, so it can charge level 2.
Excellent. Okay, yeah. Cool, so hopefully there'll be a bit of a hill climb day for EVs, which would be really good. I'd really like to see more sort of social events for the space, as well as these more formal meetings where we get to learn, but actually an opportunity for us to come together, show off a bit, have some fun, that sort of thing. So yeah, we should work with that King Lake group a bit more closely perhaps, and help them to design the day so that it works for everyone. So I actually know the fella. I sold him some solar about 5 years ago, the guy who's organising it. So yeah, I'll try and get a better update of what's happening there anyway. So the other part of what we cover before the meeting is just around the garages. Anyone who's got EV projects going on in their garage at the moment that may be taking longer than they anticipated, or maybe causing some sparks to fly in your relationship, or what? Anyone? Yeah, Bryce?
I imagine you have someone who wishes to short circuit the process of waiting. Sorry, enjoying the time with the vehicle over it. There's another blade Mark IV come up with a blown battery pack.
Okay.
Eventually that one's burning holes up in Sydney, but the car's in Melbourne.
Okay.
She wants about $12,000 for it. So I've got her contact details. I can give her email address.
Okay, so that's a blade for 12 grand, and the batteries are still working, still okay?
No,
Or,
that's the stuff.
no,
It's
okay.
new battery manufacturing system, so
but everything else is great. Okay,
I've seen the car.
Interesting. okay, great.
So I've got one at the moment. The Victrix I converted in Melbourne. I noticed he contacted another member on the Sunshine Coast. So I'm doing a conversion there. So I'm building the battery packs up, and it's being freighted up. The guy's going to pick them himself.
Oh, fantastic.
Yeah, so it's on the Sunshine Coast.
Oh, excellent. For those of you who don't know, Paul builds up batteries from individual cells, so custom built basically, custom shaped, everything like that. And we're working together actually on developing that a
There's a
bit.
few things that we've done together, isn't there? Like
Yeah.
the trike and that, so,
Yeah, that's, I may as well say at that point what's been going on in our garage. Dean and Paul actually designed a custom battery pack to go in a trike that's normally electric with a 200-watt motor, but we put a larger motor in it for Dolomiti electric bikes in Carlton. So they designed a battery that was 24 amp hour, 48 volt.
yeah, it was.
So it was actually a bit of a unique shape so that it could fit into the slot for the batteries designed for the trike, but it was bigger. So it came standard with a 10 amp hour battery, so they're obviously going to get a lot better range with that. It was a really fancy Italian trike too, so it actually stayed solid on the back, and the whole front chassis end, if you like, could pivot. So cornering and handling was fantastic on that trike. So if anyone knows anyone who wants to get a vehicle for stability, it's a really good one. Not cheap though. I think it's probably worth about $3.5 grand from Dolomiti. So yeah, that's what's been happening. I just thought of an event actually, going back to we're running in association with Holmes Glen, who are competitors in the RACV Energy Breakthrough, which happens in November each year. So it's schools build vehicles to human-powered vehicles. They have different classes, and essentially they run 24-hour race overnight with a series of drivers. They've got a massive waiting list for the pedal-only section. So the RACV are actually promoting the changeover of these vehicles to electric, so that more people can actually get involved in the race and the electric section can have more competitors, which is fantastic. So we're actually delivering Ourselves Rev Bikes and Newy Bikes are delivering a workshop day on the 20th of June at Holmes Glen, and inviting all schools to come and essentially to convert their HPV, you know, like velomobiles, so into electric, so usually with hub motors. So yeah, that's something coming up. Yeah, anyone else got any other projects on the go? Mario, you were saying something about a leakage?
Yeah, the 12-volt battery, if I don't use the car for 3 days, it goes flat. I've been able to isolate it to the DC converter. When it's on, it just shows me a 0.5 volt leakage from the 12-volt battery through the DC converter.
Right.
So the thoughts at the moment is a relay, perhaps something this year, to come on.
0.5 volts or amp?
Sorry?
0.5 volts or an amp?
0.5 volts.
It wouldn't be volts.
Maybe if the battery voltage dropping 0.5 volts.
Yeah.
Is that what you're saying? Yeah.
Just right. But if you leave it, you don't have ignition on to get the main battery back to charge the 12-volt battery, it just goes flat.
Yeah.
And then it hasn't got enough power in the battery to engage the solenoid and the main contactor.
Yes.
So you start a motor.
To charge the battery.
Oh.
That is standard for EVs.
Yeah, well, the manual says there is a loss.
Yeah, 3 days is about, it's actually fairly good. My plate does the same thing.
Yeah.
We fixed that with the lingo and the safety.
Did you put a relay on
Multiple things. We put a relay and a timer, so it actually charges every second day off the battery pack.
it? Okay.
And it's also a relay. Because with the Mercedes and the Lingo, it had to be on all the time. A whole lot of the AC systems you can't turn them off.
Yeah.
So we had every second day they charge the turn the battery pack and just charge the DC through the DC-DC, as well as having a relay that would cut the DC off. So the same relay would be turned back on. So that relay would be off DC-DC when the car was off, but it would turn on every second day and charge it up during the AC. So we'll use half of that with the relay that goes on the ignition.
Yeah, exactly.
The DC system doesn't.
That was anything I was thinking of doing. So that's the next thing on the weekend, I suppose.
Great.
Yeah, I know.
An excellent example of brains coming together and sharing of knowledge. Very good. Cool.
Yeah, but another one for short circuit
Yeah.
conversion processes. There's a guy who's involved with Hepburn Wind, but it's a long story. He's actually trying to set up a Nissan Leaf group buying scheme. Okay, I can give his phone number and details for anyone who might be interested. He's basically setting it up over the next 2 weeks.
Great. So they did bring the price down to just under 40 too, didn't they?
37 on road.
37 on road. So that's the kind of thing that really gets the market a bit more inspired, I think, is that price point has always been a bit of a barrier. So all those steps that are happening are really positive for our movement. Excellent. A buying group, that sounds really a great idea. Yeah, cool. Who would be interested in buying a Leaf if it were maybe 35? Yeah?
They did a sports model.
Sports model. If it looked like a Tesla.
And went like a Tesla.
And
It was
went-
35 grand.
Excellent. Anything else? Projects around the garages? Maybe not. All right. Cool. One thing we've started doing for our meetings is what we usually do to cover the cost of the tea and coffees and things afterwards, which is where all the sparks fly and all the shorts get circuited. That doesn't make much sense. But for those of you who have been along, that's where we all really get to mingle and meet each other and learn about each other's experiences and share knowledge and those sorts of things. So there is a cost involved to supplying tea, coffee, biscuits. So we asked for a gold coin donation, and we've decided to actually run a door prize alongside that. So for everyone who donates $2 or more, you can go into the draw to win a prize. So we get the prizes donated usually from the ATA, This month, though, the prize is a book which was kindly donated to us a couple of months ago. Our speaker was Brian Garsden, and he spoke about gridlock and his ideas for actually circumventing individual transport in the form of cars, and offered some insights to his alternative, essentially planning structures and those sorts of things. So from what I understand, the book expands quite a lot on what he spoke on. Of course, if you missed the presentation, you can see it on YouTube. So if you're out there watching in the Ethernet, you can also watch that. And so this month we're actually auctioning off, so to speak, the copy of this book. So perhaps, David, you might like to come up and I can hold the little bag of tickets and you can draw the lucky door prize winner. All right. All right. There's no bias here.
Number is number 8.
Number 8. Excellent. Well done. Some healthy EV-related reading for you to do at your convenience. The other announcement that our group has to make, and I might invite Mario up to do this, is that we actually have an award to make. Every year we give an award to a participant in our group who's made the largest contribution. So I might let Mario speak a little about our winner. And
well, before we announce the winner, it's a big apology, because with getting the printing of the name and the person that's won this has taken some time. Normally the engraving doesn't take very long at all, but we found on this particular plaque it's actually printed on the plaque, so it took a bit longer to do. But the person that the award goes to for 2012
yes,
is Mr. Michael Farrell. Thank you very much, Mike. It's a plaque, Chairman's trophy that we have.
make sure the camera can see
that we have, and it's just awarded to the person that the committee will take a vote on who we feel was engaging and also assisting the EV club. So, Michael, thank you very much. It's all yours for under 12 months. So we apologise for the delay.
Well done,
so
Mike. Thanks very much for your contribution. Did you want to say anything about what
no,
you've...
that's all right.
Good on you anyway. Oh, that's just a hand. Thanks so much.
Thank you.
Yes, well done.
Cheers. All right, so hopefully there's plenty of aspiring assistants out there who are striving to achieve that plaque for next year's awards. Okay, well, I think that concludes the official part of what I have to cover. So I'd like to introduce Justin, who will introduce our speaker for this evening. Thank you.
Evening, everyone. Tonight I have the pleasure of introducing Kristian Handberg, who probably doesn't need too much of an introduction because a lot of us would know of him already. Kristian works in business development for the Australian technology company DiUS Computing, and a lot of you probably know him from his former role as the project manager of the Victorian Government EV Trial. So in that role, Kristian had a central position in the emerging EV market. He's a master's qualified engineer with a passion for technology solutions for society's problems, which is probably something we can all identify with ourselves. So tonight Kristian will be talking about DiUS's recent work on smart EV charging, and we're quite lucky with the timing in that DiUS only yesterday, I think, released their big report on the research they've been doing into that topic. So smart charging VVs is something that has been talked about for quite a while, but I think now it's been proven that it can be a reality, and as I'm sure Kristian will proudly tell us, it's a bit of a world first, the research that they've done, and And it really is one of these situations where it's a win-win sort of for everyone, really, for EV drivers, for the electricity networks and all electricity customers, and can help with environmental benefits as well, you know, incorporating renewable energy. So I'll hand over to Kristian.
Yeah, so that was an excellent introduction. Thank you, Justin. So I probably don't need to really explain who I am for those who don't know me, but I have met quite a few of you before, so I'm surprised you're here, really. That's basically it. Today I'm going to talk about the project that we did over the back end of 2012, and I was actually on the opposite side of the fence at the time this got done, so I was working for the project sponsor in Victorian Government, and this was delivered by the company I now work for, which is perhaps not such a coincidence, it could be said. I'm going to explain about what the project was all about, and I'll go through the other obvious things that are written there, so I won't dwell on that. The project was delivered by DiUS primarily, but there's some pretty important project partners who are represented here in part. So Julian de Hoog is from the University of Melbourne, and they helped out with some modelling, and Julian was very helpful during the planning stage of the project. United Energy, it was run on their network, and that is the area out sort of through Vermont and that sort of thing, if you live out that way. I know some people do. And the Alternative Technology Association, Craig Memory, for any of those of you who know him, he's the energy advocate for the ATA, which means that he does the heavy lifting on policy type stuff, and he was involved as a steering group member. So it was certainly not just DiUS's efforts. The objective of the project was to demonstrate that you could manage electric vehicle charging using what is now Victoria's smart grid. Now that's quite an important thing, because obviously we've spent a lot of money on these smart meters, and they've got to be good for something, obviously. But then separately, this was the first occasion they'd been used for this sort of task, where we were actually going to see an electrical load on the end of the network and control it through the network. And that obviously has broader application than simply just electric vehicles. So a very common question in this space is, what is a smart grid? So obviously many of you may have mixed emotions about this. This is the smart meter which is installed in many of your homes, or it will be installed by the end of this year. That is the most visible sign of the smart grid, and the smart grid definition is really an advanced electrical network that uses digital sensing, computing and control to be able to basically get a more efficient outcome. So electricity networks were basically conceived and have grown over the space of the last 100 years, and they use largely analog type systems, but that's changing because those systems are not very good at seeing things in real time, and by virtue of putting in digital sensing and control, you can get a lot greater efficiencies. And so what that actually looks like, if you were able to sort of extract it from a actual physical viewpoint, is that you get currently the back-end systems. This is where the electricity distribution is controlled within the building. That is the utility, the electricity distributor, which is United Energy in the case of this project. They have what is called a neighbourhood area network, or sometimes the utility wide area network, and that basically goes through the power systems, through the transmission, into the zone substation areas, and then down through the power lines to your smart meter or your digital electricity meter. And then in your home, there is a network which is the consumer home area network, and that is able to communicate to a range of devices. So depicted here are two of the devices that DiUS does, and that is the ChargeIQ system and home energy monitor that goes on your fridge and basically can tell you in real time what you're using energy-wise. So that's what it basically looks like, if you could see it like that. And you can see that basically what happens is that the utility can see what's happening there in real time, as opposed to having to dispatch a man to go out and look at your meter every 3 months, or make an approximate guess based upon what they might think that you might have used. So that brings the networks up to today's age in terms of control, etc. So why electric vehicle charge management? So this is one of Julian's excellent charts. So you can talk to him about this. I'm not going to steal his thunder, but this is a depiction of what is a normal household electrical load within the region that was where we did the deployment of the cars. The additional load that is the EV charging load just goes straight on top of the highest peak load for the household's energy demand, and that's because it reflects how you use cars. You get home from work and you plug the car in and it starts charging up when you get home, and so it just adds to demand. And that, I mean, you can look here, that is, say, roughly between a quarter and a third higher again. And what is driving a lot of the costs in our electricity networks is this peak demand issue. You basically build the network to cope with the times of highest demand. It's sort of like the roads or the public transport system. The reason why there's traffic jams, etc., is because there's over demand for the capacity that there exists. And electricity networks, they have to be extremely reliable, and that means that we're having to build networks to cope with higher peak demands from air conditioning and the like. So I've been a bit convoluted in my explanation, but it'll sort of come to light as I go along. To control electric vehicle charging, there are a range of options. Obviously, you can go out and just pull the plug out or put it in according to when you want to charge the car. That's a fairly manual process and not really that helpful if your off-peak period starts at 12 o'clock at night. The Nissan Leaf has a charge timer on board the vehicle, and so you can set the charging according to when your off-peak period begins, but it doesn't have any relationship to what's happening in the network at any particular time. So you can take advantage of your off-peak tariff for your solar, but it's not going to help the network operator, for instance, if there's other reasons why they need to be able to see what's going on with the charging. These dedicated electric vehicle chargers, like this one here, they also have the ability to control the charging, but again, most of them, they don't have any connection to the grid beyond that to supply electricity from it. So they don't currently talk to the smart meter. The smart meter through that home area network is not talking to this because this device is not designed to do that. So there's a variety of reasons that we won't get bogged down on it. What we have got at DiUS Computing is the ChargeIQ system, and the way this works in terms of that smart grid layout is that this is the smart meter that is the home, and this is this sort of backhaul network that is the utility. And the AMI mesh radio network is quite a jargon-laden term to describe that utility area network that goes from the electricity distributor to the smart meter. And they can see your smart meter in real time, and they can send messages to it from what is their demand response manager. So what would happen is that you can push a message down the line through the mesh radio network to the smart meter, and then it can basically communicate to any smart appliances from there. The smart appliance that we're dealing with here in ChargeIQ is bound to the specific electricity meter through this customer portal, and then the terminal itself is able to communicate with other aspects of the ChargeIQ system. So it's integrated with the car, so it'll charge the car according to the J1772 standard, and it communicates through to the web server, so it's got a web page, and then it can communicate onto the driver through a web page, smartphone app, their email or their SMS. And so I'll show you how that looks in real life. So this here is the terminal, and this is what it looks like to the rest of the ChargeIQ system. So the smart meter would send a message to the terminal, and then the terminal would dispatch a message through to the person's email address. They could see it on the web page. Once they logged in, it goes to their smartphone app on their iPhone, or they'll get it on SMS. And so that allows them to see what's going on with the charging at any particular time and control it through the smartphone app or through the web page. So what we did in the project is that we obviously installed those basic elements, the building blocks, in order to be able to charge, to control and see and control the charging. So the ChargeIQ units were put into people's homes. They were bound to their smart meter, and we were able to see the charging load on the end of the line from United Energy. We then designed a range of charge management scenarios that reflect what are real-world network scenarios. So typical scenarios that we would describe would be what's called emergency charge management. That's when there's an unplanned outage in the network. And that would be, for instance, when there's a thunderstorm and a transformer gets blasted unexpectedly, and there's a failure in the system, and you get a choice between, okay, well, the whole network in a region might go down, or we can shut down certain loads in order to preserve the rest of the network and therefore allow for higher priority things like you know, if somebody is in a retirement village or something like that, they would obviously, you don't want to deprive them of power and things like that. And then there's planned outages in the form of maintenance events, so there might be an upgrade going on to the transformer at its own substation, or there's sort of anticipated periods of high demand, and they usually coincide with peak weather events because it basically reflects when everyone's going to turn their air conditioner on. So the difference between an EV charging load and an air conditioner is you want your air conditioner to cool you when you're hot, but you can have your car charge whenever it suits you around the times of electricity being cheaper, and that means it's a transferable load. Another example of that might be a pool pump, for instance, because you don't necessarily need to have your pool filter running in the periods of peak demand. You can have it transferred to another time, and those are sort of loads that the network would like to manage. So we designed a range of charge management scenarios that were a reflection of either an emergency charge management event, where we basically have it happen on a very short time frame in terms of people getting notification, or we have what's called a scheduled charge management event, which we described as let's see, it was peak charge management, and that was where the householder would get advance notice of about 24 hours that there was going to be a period of time over which their charging load would be deferred, and then they could make decisions themselves about what they would do, whether they needed to have their car charged beforehand, so they'd plan around that, or they basically just wouldn't do anything because it didn't really make any difference to them. That was communicated to the householders through those range of things. So these are messages that they received in advance to be able to tell them what was going on, and then they have the option of opting out of those charge management events, which means basically they're overriding the utility from managing the charging of the car in order to choose to charge their car, but they will do so at a cost. So we just set it up to reflect an approximate cost of about $5 to be able to override it. That's probably a little bit more than what you would actually pay, but it's a price signal that reflects the choice that you would make in the real world, which would be, okay, well, I'm going to use electricity during a period when it costs more. So that's how we tested out whether people were going to go for that idea or not. So we ran that. We ran those charge management events. We put 64 charge management events through to the 8 households who ended up being able to participate in the trial, and we measured what happened. So in the setup phase for the project, one of the things that we found is that not all smart meters are able to be talked to because they're in locations which are remote from where the actual the household is using their smart appliance. Now that might seem like a complete jip, but one of the aspects of the smart meter design is they use a relatively low power communications protocol called Zigbee. And Zigbee is designed to be low power because it's a constant through the whole network. It's operating all the time, and it's in every household that's got a smart meter, so you don't really want it to be a high power communications protocol. So it means it's relatively low transmission power, which means that if it's in a housing estate like a new development or an apartment somewhere, then in order for the smart meter to be able to be seen by the household, it's got to be close enough to the meter to be able to see it. So we found in one of the 9 households that we were putting these into, in the end they couldn't do it, couldn't get the smart meter to be seen by the smart appliance, and that's when everything is to spec. So that's an issue for the networks and for the effectiveness of the smart grid. And the system performance. So we measured how long it took for a message to be sent through the network and then responded to by the smart appliance that was the ChargeIQ terminal. And what we found is this is the time lapse between its histogram of the time lapse of all the messages and the distribution, is the majority of them were happening pretty much instantaneously, within a few minutes at most, and that's adequate for being able to manage charging loads or any electrical load down the network. But there was a couple of outliers, and they're things that need to be addressed mostly within the ChargeIQ system, but they were things that weren't quite clear as to why those messages were deferred. But there was a distribution nevertheless.
Sorry, just one question. Those time frames, are they even suitable for like the emergency response situation?
Yeah, pretty much. Yeah, obviously they have to make decisions fairly quickly around charging loads, but you can see the majority of what's happening is happening within 4 or 5 seconds, and so they can dump a hell of a lot of the load off the system, which would be lower priority load, you could say. And so this is this sort of difference between the current electricity networks that most people have got and what is a smart grid, an ability to be able to choose where you need the energy according to the supply and demand balance at any particular time. So that's better than obviously having whole suburbs black out with no discrimination between what's important and what's not. You can basically set it up to choose, and that ends up with a cheaper network as well, because you're not gold plating the network to ensure you've got reliable supply at all times.
And sorry, I forgot to mention to everyone that you can jump in with questions.
Yeah, I'm going to just rattle along otherwise, and I know that it'll be...
Those times that you quote, I assume that's from when the grid operator sends the command till it receives an acknowledgement. Is that right?
Yeah, so we had a timestamp of exactly when the message was dispatched from what's called the demand response manager at the utility, and then we have a timestamp on when it was received by the ChargeIQ terminal.
Oh, okay.
So and then we just subtracted them.
Okay, so it could actually be a bit longer before the network receives the acknowledgement. But
oh no, it wasn't received by the network. It was a measurement point that we took from the terminal itself. So it wasn't. It didn't bounce back, so to speak. It was literally, there was a timestamp of when it was dispatched, and then separately we had a timestamp of when the messages were received on the ChargeIQ system. So different systems, and they were synchronised.
The network doesn't know if the ChargeIQ has successfully received the message yet?
Not necessarily. No, it depends how the system is set up to operate. The standard is this Zigbee communication standard that applies to our smart grid, and the way in which the messaging clusters work and the functionality, and that's still sort of unfolding at the moment. So this is we're one of the most advanced markets in the world for this sort of stuff, and in California is another advanced market. They're only commissioning this functionality at the moment. So a lot of these standards are emerging at the moment around how this messaging would work to be able to see. It would be tailored according to the specific purpose.
Is the ChargeIQ terminal an interface to a standard charger, to the manufacturer's charger, or is it a whole charger and interface?
You can think of it as almost an integration point. It integrates the car, which is done through the charging standard, the J1772 standard, the network, which is this Zigbee thing, if you like, the Zigbee communications protocol.
Do you attach a little box to the charger, or do you provide a whole charger?
No, it's a whole charger. Yeah. So that terminal is something which was designed and built by DiUS. So the whole lot there's nothing bought off the shelf. Of the cable and the plug, yes, are basically bought from Yazaki, I think it is. But yeah, that's basically it.
Kristian, the use of the meter there, is it merely a communications channel? Is there any other functionality that the meter provides other than an interface with communications channel?
Well, inevitably, I mean, it is a meter, so therefore it's measuring your electricity use.
With respect to the car.
Oh, with respect to the car, so this is the smart meter.
Yes.
From the meter's perspective, the car is just an electrical load. There's no differentiation between what the loads are. It just senses it as a load and measures it accordingly.
The ChargeIQ terminal is not a sub-meter.
It has sub-metering in it as part of the design, but it's not not a billable meter, if that makes sense. I'm not sure how far you are with the electricity market, but it has a metering capability, so we can tell how much charging energy has been consumed through the terminal, but it's not used for billing purposes. It's not.
So that wasn't part of the trial.
It's just not currently able to be done as part of the electricity regulations. So even if you have what's called a revenue grade meter, you aren't able to have a sub meter on your premise. This was a big problem for Better Place. It wasn't the reason that sunk them, but it was a big problem for them. But that's just a characteristic of the regulation of the electricity system.
So it used the meter as a communications channel and nothing more.
So the complete set of the meter functions is that it obviously measures electrical consumption for the property, the residence that lives beyond the meter, and it communicates in next to real time with the network, and it's got this home area network functionality as well, which is not currently open access.
So the ChargeIQ, since it's designed to a charge standard, I can charge up any production EV and not void its warranty?
Yes, although we are deliberating. There is an integration aspect to the design of the system, which is just about product development, if you like. We don't have a retail product currently. We're working business-to-business type stuff. So the answer to your question is yes. If I'm trying to sell you one of these things, if I'm actually going to get a contract, if you literally want to do it, then I'd say, oh well, give us a few months and I'll sort it out for you, sort of thing. So depends if you're looking to give me a big contract for 1,000 of these things, because I'll do it for you in a few months if that's the case. Especially if you've got a Volt.
Simply is just doing the home area network. It's
Yes.
not doing the network back to the demand.
No, it is. It is. Yeah, there's the Zigbee through the utility area network, the neighbourhood area network. That's Zigbee. The demand manager communicates to the smart meter using the Zigbee communications protocol.
Urban areas, I presume, not in rural areas.
No, that's full stop. So the 2.66 million households and small businesses in Victoria that are getting smart meters, it's all the same. They're all on the same system.
That distance.
Yes, so through the network. I mean, it goes through the power line sort of thing. So.
The map that you showed before where the ChargeIQ terminal was too far away from the common meter, if it happened to be close to the neighbour's meter, could the neighbour's meter signal your ChargeIQ when to...
No, and the reason, so I've skipped over a lot of the complexities of the network, but the way it works is that the terminal is supplied with its own unique identifier, as in the individual terminal. It's got what's called a MAC code, and every smart appliance has got one of these. And then it is bound to the specific smart meter ID, which is your NIMI, if you're familiar with that on your bill, which is a unique identifier for your electricity meter. So the networks have got what's called a portal, if it's customer facing, and you can go on there and register the device to the smart meter, and then it will talk to your so when the network is talking to your smart meter, then there is an appliance bound to that at the end of the line, and the network knows that. So obviously that's, that could be all 2.66 million meters with any number of appliances hanging off them, and you can see where that could get out of hand pretty quick. But one of the complications at the moment is that there is no requirement for the networks to have what's called facilitated access, to allow parties to bind appliances to the meters. So that's an area of discussion, I suppose you could say. So I'll get to that. One of these, if you are genuinely interested in this stuff, I highly recommend having a look at the report, because it's quite detailed in terms of a lot of this stuff. And I thought I'd try and skip over it for the sake of getting the bits I thought you might be a bit more interested in. But it's great you are interested, to be perfectly honest. What else we found out about the demand management events? So one of the things that I thought was really interesting is that the ChargeIQ terminal comes configured with a default that is to the smart charging setting. And so basically, if you turned your ChargeIQ terminal on, then it would normally default to the off-peak period, the smart charging period. And what we found, and this is a thing, has anyone read a book called Nudge? It was written by a couple of Harvard guys who, it's basically a behavioural economics type thing where things like, say, superannuation, people just go with whatever the form says. People don't look at what it is, the majority of people, they just basically go, whatever, and they just, so there's been a line of thinking that is the defaults on things, on all things, should be what you want people to do, as opposed to letting them choose it, because people don't think about what they're choosing most of the time because they've got other stuff on their mind. So the ChargeIQ, this demonstration project proved that, because there was only one household that was on a time of use tariff, but the majority of households used the smart charging mode because it was the default, pretty much. That was what it was doing by default. And they didn't interfere with that because it wasn't affecting them, and it required more effort to interfere with it than to not interfere with it, so therefore they left it. So that was interesting in itself, because it suggests that, okay, firstly, there doesn't need to be a financial benefit here, it can just be set up to operate this way, and people will sort of just go that way as a matter of course. So that was sort of interesting.
Did the book Nudge take into account engineers?
Yes, but the engineers are a minority in the community. As an engineer myself, my laziness wins over my engineering every time, and I end up not looking at my super forms or anything like that, so I've got no idea what's happening with them. But so default would work with me even. So there is a minority group, obviously even amongst the engineers, who that still works with probably. Now this is a dazzling chart of figures, and you'll be pleased that this is the only one that I've included like this, but I'm going to go through these a line at a time to explain why they're significant. So obviously, the total charging loads, that's sort of interesting. This charging duration, obviously there's a fair standard deviation here, but that time reflects basically the distance that people were driving on average. So the duration of time is 2 hours 35 minutes, basically reflects an average driving distance of around about, say, 30 k's a day, roughly, that people were charging. So when people are thinking about, that the car charges for 8 hours, well, it might do, but nobody's really driving it to the extent that, and this comes back to what we learned in the Vic EV trial in itself. People don't change their driving habits as a general rule just because it's an EV. They basically drive like they would normally, and people drive normally about 30 to 35 k's, and so that translates to around about 2.5 hours of charging time overnight. So that's not a long period of time, and it's a pretty fair window that can be moved around within, because it's from the moment that people get home to the moment that they go out in the morning as a general rule that window exists to be able to put that charging in. The total on-demand charging load, that's obviously just a big figure there, but the guts of it is that as we go through here, the majority of the charging load was shifted to the off-peak period just by virtue of that default setting. And then for the charging loads that were affected by those charge management events, they were, again, the majority of those were just under the majority, actually slightly, 49%. That tells us again that people, by and large, were pretty comfortable with this direct load management by the utility. So that's sort of interesting from a...
Kristian, just, can you go back?
Sure.
You haven't got there the household consumption anyway.
No.
But that shows about 5 or 6 kilowatt hours a day on average for the car charging. The household was probably slightly more.
Yep.
So in a sense, having a car charging and EV charging was like going from a house to a dual occupancy on the site.
Yeah, I mean, there is a very wide spectrum in terms of household energy use, and if you look at...
Yeah, I saw one that used 80 a day the other day.
Yeah, so there are some people who obviously, living in their McMansions with every light and every heater going all the time, and then there's people who are basically living on their own and living out of the house and then living like monks the rest of the time. So that spectrum means that, it can make a big difference to your household energy load, or it could be a relatively small contribution.
I was thinking about the utility load.
Oh, the utility load? Well, from the utility perspective, it represents a risk if it's unmanaged. So the CSIRO modelling that was done for Victoria said that unmanaged, it could lead to 30% increase on the network load, and that's obviously not a good thing, because that means we're going to have to build a network that is 30% more capable than the one we have currently, which is going to cost us all. That doesn't just affect the EV drivers, that affects everyone. So that's a big deal, and so the networks obviously, they look at that as a big risk because they get penalised according to network reliability, and that's what it would impact if they didn't do anything to manage that issue. And then separately, the other issue for the networks is they don't know which households are going to get EVs, so they don't know where they have to augment the network, and therefore they've got to do the whole lot in some respects. So this is where, well, what is a lower cost pathway to getting that solution? And we have these smart meters that theoretically could provide that, except for the fact they can't see the car currently. So that was the nature of this project. So
in terms of the consumption, probably on average, better say an EV would increase the average household consumption about 50%.
Yeah,
increase so sometimes it can double it, but probably 50%.
Yeah, that's ballpark, so real ballpark.
It is a major addition to your consumption. That's probably where the utilities see the opportunities as well, because that's more sales for them. There's potentially there's the risk
not so much
costs on one side in terms of the peaks, but then there's also the increased volumes and sort of
so there's a whole line of discussion around what's called the utility death spiral, which is to do with the impacts of distributed generation on the utility business model and the decreasing overall demand that is happening completely against historical trends. And that's massive topic, and one which you would really have to have a quiet day indeed to want to get into that. So I won't get into it.
Is that based on that American report?
No, in fact it's local. So locally, so AGL did a particularly good paper on this. They've got a sort of a policy area. And I can send around the link if people are really interested in it. But the guts of it is that utilities are on a bit of a hiding nothing at the moment because the way the trends are going, they're not able to. They've been on a pretty good wicket for a long time, but that's not going to stay that way, and there's not much that's in their control to affect that. So that's what they're all not very happy about, and they will obviously insist on fighting for the status quo as a result. So I'm out of government, so I can say what I like. Yes. So one of the other things that's characteristic of the cars, and you would all know this yourselves, but this is a charging load from a Mitsubishi IMU, and what's really significant here is the charging load is highest when it begins. And that's interesting from the perspective of if all the cars start charging at once, then you go from nothing to lots straight away. And that's what's happening in San Diego and San Francisco, because they've got a time of use tariff and the cars are on it, but they're all charging at the same time. So that's where, again, the sort of uncoordinated approach to the charging will lead to. So that was interesting, and we saw that. So this is again the only, this is the slide with the most writing on it. We asked the participants what they thought. Now this is anecdotal because we only had 8 participants ultimately, so that's why it's a demonstration project. But we still found out some quite interesting things here. So firstly, the peak charge management events is where they received 24 hours notice that it was happening, and they were sent a message on their SMS, their email. If they had an iPhone, they got on that and on the web page. So the majority of them noticed that message. So that's good to begin with. So I'm a little bit haphazard with my phone, so good on them for paying more attention than me. And then they took steps where they were going to be affected. So that means they either managed the charging or managed the use of their car to reflect the fact they knew there was going to be a period of time where they weren't going to be charging the car because the utility was going to want to do it. They could override that if they wanted to, but the majority of them didn't do that. They just took steps to work around the fact that it was going to be, and they got a $5 benefit as a result of having done that, which would be analogous to the real world. However, the emergency charge management events where they literally got less than an hour's worth of notice, they sort of came and went before anyone realised it in the main. So we asked them, did you know it was happening? The majority of the time, they didn't even realise it had happened. So they got a message and it was like, oh, okay, last night apparently the car wasn't charging and I didn't do anything about it. So that was sort of interesting in itself, because again, it wasn't really impacting upon them in the main, but they were pretty much unaffected, I suppose. So we asked them what they thought about all this. So we gave them a lot of guidance around what was going to happen and all this sort of stuff, and they were pretty happy about it. But unexpectedly, they actually said that they would be happy to play ball even if there was nothing in it for them. So because it wasn't making any difference to them, they were pretty comfortable with it. And there's a line of argument that suggests that people won't play ball with this stuff unless they're getting a benefit themselves. Well, that's not necessarily the case, it would seem. It's not for everyone, but there was a significant number amongst our very small sample size. They weren't that keen, though, however, to cede control over completely. So they like the idea of having the utility do it, but it needs to be sort of a negotiated outcome where they're allowed to retain some control. And that's consistent with what was seen in Townsville, where Ergon ran a very similar experiment, and they have what's called a tariff 33 for pool pumps, and it's a hard tariff. The pool pumps only run at certain times. There's a big blackout period where they don't, and they found that with the EVs, people weren't that comfortable with that idea. They wanted to know they could charge the car if they needed to, and they were prepared to pay a premium for that, but they wanted to retain some element of control. They felt that the ChargeIQ system was a very key enabler for all this, and that's to do with all of those SMS messages and all that sort of stuff, and the ability to control it sitting where you are now with your smartphone. And that and of all the things they found useful, it was the SMS notifications, the ones that struck a chord with the most. So that was sort of interesting in itself. So what does all this mean for the drivers? If you just adopted smart charging, it won't surprise you, because many of you are probably on a time of use tariff for your solar PV. Well, you're just going to get 50% of the cost. That's basically it. So that means that for our drivers, extrapolated over the year, it would only cost them $250 for the whole year to charge their car. So that's not a bad deal, really, for personal transport that goes where and whenever you want it to go. So that's a pretty good deal. And the issue was there was no cost associated with it, so they didn't actually have to sacrifice anything. They didn't have to go to any effort. So there was no impacts upon them, and yet a big financial benefit for them.
How much would it usually cost to buy a ChargeIQ though?
Yes, well, this is an issue for the utilities and the government, I suppose you would say, because the technology is not. Well, it depends. It depends because there is a broader societal benefit here, and I'm not lobbying for it because I work for the company that's making these things, but more just in the context of the technology does cost money, and if the payback is beyond what is a reasonable time frame, then the issue becomes, well, if there's a broader societal benefit, then maybe there's a case for it. And I think the utilities themselves, they need to look at whether this is a lower cost approach for them to run their business, and therefore would they be better served to invest in this sort of approach than to go out and gold plate the network, for instance. So which brings me on to the utility benefits. So one of the really interesting things about this is not just that EVs aren't a disaster for the networks, but in fact they can actually return, provide better returns on existing investments, and that's because you get a better utilisation of your assets if you're able to put the electricity demand out more smoothly. So if this curve gets smoothed out, if this is a flat line, then you can run your network very efficiently by comparison with it jumping all around. And that means that without them having to spend any money at all, they could get a much better return on their existing assets. So that's an important thing in terms of them considering, well, which way should they go with this stuff. They can use EV charging to be able to address some of these issues around this death spiral that I was talking about, and that's something which the utilities are starting to think about. Now this is sort of higher, bigger picture type stuff because this is to do with sort of the policies around the smart grid. But the guts of it is that when I said before that people can't currently register devices onto the smart grid, well, that's not necessarily going to change because there's no requirement that the distributors allow you to register a smart device to talk to a smart meter. They are yet to decide as to what is their preferred approach, and if they decide they don't want to allow anyone to access their network, they won't, because the regulator usually has to make the utilities do everything. They don't do anything that they don't want to do, unsurprisingly. So that's a real issue, and then separately, if they come up with different arrangements, then for each of the smart appliance providers, they might have to come up with a different approach for every network operator. We have 2.66 million smart meters in Victoria spread over 5 network operators. That's a pretty small, down to its smallest level at Gemini, I think that's only about 200,000 or 300,000 meters. For every appliance manufacturer in the world to have to tailor their approach for small markets of that size, that's not going to work. But unfortunately, that's the way the market is going to go unless there's some effort put in place to standardise the processes by which these things occur. So this is something that happens in the energy market more generally because the distribution networks have a regulated monopoly and they operate it the way they want to within the bounds of whatever they're regulated to do. So that's the way it's going to unfold, unfortunately, because this part of the network's not regulated, basically. The consumer access and confidence in the smart grid, we think it would be improved by addressing these issues to do with getting access to the consumer hand. So you could get a smart appliance like an energy meter, and it would tell you how much energy you're using, but only if you can reliably connect to your smart meter, if the communications from your smart meter are reliable in themselves, and there's a pathway to be able to resolve issues, and none of that currently is dealt with. So if your smart meter won't communicate to smart appliances, then well, that's your problem to figure out and solve, even though theoretically your utility owns that asset. Well, they don't theoretically own it, they do own it. They own the smart meter, but it's going to be your problem if it doesn't do this stuff. That's the way it's set up currently, and we don't think that's ideal, so we think that that's something that should be looked at. And thirdly, the company I work for, we've innovated these technologies, these smart meters and these energy monitors around the Victorian smart grid. It's an innovation platform, effectively. It's like the NBN, but for the energy system. And because it's using a standard protocol, a ZigBee protocol, it's a globally recognised standard, we are looking to export this technology to the global market. However, it would be much easier to innovate if there was a lot more clarity around how the smart grid was meant to operate. So we think that that's something that could get looked at as well. This is even more arcane, perhaps it could be said, but we think that obviously if you're looking at electricity demand management as a way to be able to try and keep costs of the network down, then some of the things that we figured out to do with communicating to consumers would be best taken on board, and then separately the utilities just need to be clearer to the market about what they expect to do in that space of demand management. So that's a bit dry, but I'll get into stuff that's more interesting. So what's going to happen? The future, or in fact the present, because this is the present. Nissan have got a Leaf to Home device that they've already delivered into the market in Japan as of around about the middle of last year. And so within your closed system that is your home, you can pull energy back out of your Nissan Leaf and use it to run your home during periods of tsunami and nuclear accident, for instance. That is something which was not a coincidence, of course. So, but that's emerging. Mitsubishi have got a similar thing, and that's not that complicated, really. It's sort of like an inverter, if you like. The car's not really set up to do it, but Nissan obviously have designed a proprietary solution for their proprietary product, and it means that it is happening. So you guys, having built your own cars, you can probably build your own solutions to these things, and that might be something to lose a few more years of your life on weekends doing. So I'm sure many of you are champing at the bit to get home and start working on that now. Vehicle to grid, again, the future, but the present, because in Delaware they actually have got vehicles connected to the grid selling energy back into it. So that is something that's quite significant, because the utilities, of course, you know, their heads turn 360 and their eyes roll back when they start thinking about the regulations around these things. They're compliance-driven organisations. But if you have a utility that's on board, this is at the University of Delaware who've driven it with a local utility, I think PGM, I think it is, and they are selling energy back into the grid. So that's really significant, because that improves the business case on your car, for instance. So I'm using jargon there. Basically, it'll make more sense to have an electric car if you can use it to do this sort of stuff. The market doesn't currently know what the effect on the value of your car is, because of the depreciation that's accelerated through the battery deterioration, but I'm sure that will emerge over time, particularly if there's a price signal in the market. And I'm strongly in favour of there being a price signal put in Victoria, because we have this smart grid and it's an innovation platform, and this would potentially allow us to take up electric vehicles and innovate technologies around it, because we've invested in all that stuff already. So anyway, I feel quite strongly about that. The solar synergy. So this was supposedly the future, but it's happening now. So there's this dude over in, where's he? He's in Massachusetts or somewhere like that. But anyway, he's like a top-notch, absolutely world-famous geekster, this guy, because he's got his whole house covered in solar and full of gadgets, and he's done everything. He's just a big living lab, his house, and so he's got a massive solar system, and he's figured out, he's done just the financials on what happened when he bought a Volt, a GM Volt, and it basically has meant that his solar makes a lot more financial sense, because he's reduced his transport costs by virtue of running the car off the energy he's generating from solar. So that's quite an interesting article. I was actually going to do a business case for our local environment, but I sort of actually had to do my own work this afternoon instead of that. So I leave it to anyone else. If you do it, come back to me, because I'd be very interested in the outcome. I might find time to do it. So have a look at those things if you're interested.
In regards to the solar, is the ChargeIQ set up to be able to directly, like if you've got solar in your house, you can set it so that it will use your direct solar rather than waiting for the off-grid period, because you really are better to use your solar than selling it into the grid at 8 cents.
It's a very good question. I'm glad you asked. No is the simple answer. The smarts in ChargeIQ could be adapted to do that, and that would be relocating them into what would be a home energy manager. And those things are coming out. I did see that IINet launched their home energy manager at some show in Sydney today, I think it was. And it's this hub that sits in your home and talks to your appliances and figures out how much energy you're using, and you can manage things centrally. And what's happening is this sort of Internet of Things, if anyone's heard of that term. But basically, devices talking to each other and making decisions based upon if-then type statements, if this, then that. And it's easy, it's relatively easy to set up, so tinkerers are able to do this at the moment. You can basically design your systems to be able to do this by putting really low cost sensors and these things, these little modules. I don't know whether anyone's into that, but it's called, there's a couple called the Arduino and the Raspberry Pi. They're little computers that you can program and stick on anything, and they can control stuff for you and make decisions. So what's happening is that because of the costs of those things have come down, smart appliances are going to become quite commonplace, and then the next step is to have them start talking to each other, and that'll happen over the next 5 years basically. So your smart TV will, through that, so already the IoNet system, Telstra's T-Hub, those things are going to start bringing in various appliances in your home, and you'll be able to manage them through that central hub. And your solar home energy management, I don't know what the IoNet system's capable of doing, but it might actually already be able to do this sort of stuff. I don't know. It's only launched today. Again, I was sort of writing this afternoon, so I didn't get to look. Any other questions?
Can I go on?
Sure. Yeah, and then I'll come over there.
Try to figure out some of your numbers. I think with the charge controllers, you just put them onto a standard GPO, a 10 amp GPO. You didn't run a special outlet or something?
No, they're 15 amps. Yeah, 15 amps. They charged, the cars were, so it was the Nissan Leaf and the Mitsubishi Imeo, and they both pull 15 amps nominal.
Right, so you put in a separate power point back to the
yeah, separate circuit, yep. It's okay. Gentlemen.
Yeah, back to that solar part. So at the moment there's no actual, it's only relative to the grid, it's not relevant to your generation.
Correct, yeah. So
really looking at it from the people are selling you energy outlook as to what happens to your demand if it shifts the time of charging your car. There's no input for, I've got enough solar going in the middle of the day to export,
no, but I don't think it'll be too far off before that happens. So we haven't done that because our focus has been on the grid integration, and that's basically because we think we can sell this technology to the utilities pretty much because of the benefits to them. The issues that you're talking about, you should think of them in this context, which is the closed system that is your home. As soon as you start to try and trade energy back into the grid, because if you're on a feed-in tariff, for instance, you could have home energy storage or a car, and you can just basically try and work the system in terms of your tariff. So you try and store as much energy as you can, and then pump it all back into the grid as soon as the feed-in tariff works for you. Now that's something that they're trying to deal with, obviously in a regulatory sense as it is, and the very last slide I've got talks about that. So I did actually forget I had this slide, but this is a report from Victoria, and this was, for anyone who works in the space, this was the bad news report about when they reduced the feed-in tariff down to 6 cents. But the news it also contained, buried away in it, was that they valued what distributed storage would be worth from the network perspective. And so in today's dollars, they think it's worth about maybe 12 cents and change a kilowatt hour, which is because it's more flexible than solar. Solar generates when the sun shines, while distributed storage you can pull energy out when you want to pull it out, or whenever there's energy in the storage facility. And then interestingly, this was meant to be with distributed peak generation, but it could theoretically apply to just this is when the wholesale electricity market and the retail market get closer together effectively. And so there's points in time when the wholesale market goes up way above this point, but $100, and Terry would know a hell of a lot more about this than me, as would, in fact, probably most of the people in this room, so I probably should shut up. But the guts for this is that there would be an economic basis to say there should be money for making your car available to have energy pulled back out of it, because it's a benefit to not just you, but a benefit to the network. And whether you would choose to go down this path because you can control this, everything that happens behind the meter in your home, that's your business basically, as long as you're sort of prepared to live with the consequences of your decisions, then you can start tinkering with the wiring and putting your own hub in there and programming systems to talk to each other. But if as soon as it starts to be trading in and out of the market beyond the electricity meter, well, that's when you're regulated and you're not allowed to do that. The meter's not yours, it's the utilities, and the tariffs and things, that's all things that you've signed contracts for, and you're bound by the terms of supply and that sort of thing. So it depends how much you want to get into it, but it's possible to explore. It's a pretty big hobby, but you could certainly certainly within your own house, if you have a big solar system, then you'd be able to start to try and configure your charging to control it. That wouldn't be that hard to do. You would think so, yeah, and certainly, what I need to do, I mean, we're talking with other potential business partners who think the same thing, but the reality is that we need to sit down, and that gets into this issue to do with how much storage do you need to be able to make that worth your while, and how much is the cost of the storage. So the costs of the batteries are coming down to mean that it might be cost effective to do that, but they're currently at a point which means you'd have to have more dollars than cents, as the old saying goes, because you really want to do it. But that's a first mover market all over.
A few people asked me about electric cars on the horizon, and one of their main points was, well, if we buy one of those, we want to put a solar system in, and we want to charge the car.
My feeling is it's going to go the other way. I think that the 1 million and plus households now in Australia who have solar will get to a point where they think an electric car actually is a good idea, because basically the solar can keep on giving if they're running their transport off it as well, or subsidising their transport costs. So I think it's going to go the other way. There's a lot more solar households than there is EV owners.
Only if they're able to utilise like a better charging mechanism than letting their solar feed in for 6 or 8 cents.
Yeah, well, I think really the market will come up with those products. Yeah, so
people at work, it's not so practical. Yeah.
I think it's all going to. I mean, you could do it now if you were that way inclined. If you're a hacker and you wanted to get these control systems together and do all that, which there are equivalent groups like yourselves of people who are interested in doing those things, and you can certainly go online and read forums about them. But the market is going to cough up products that are plug and play basically, and that's the idea really for the majority of us, and that's where it's at. So this made for interesting reading, because this was actually just based on a guy who largely does plug and play stuff, but he just has a very big solar system. It's like he's got a 10 kilowatt system on his roof. It's sort of hard to see the house under it.
Anything particularly special though, my place where the appliances are before the inverter is before the meter. My consumption is provided by solar, assuming I have all, then I have enough to meet demand. So another load, which would just be an EV charger, would also benefit from that, so long as I overrode your time of use settings.
Absolutely. The issue is that the inverters themselves at the moment aren't very clever. The inverters just give you basically a daily consumption reading. You can't dump huge quantities of data out of an inverter currently. For the majority of the ones I've seen, they don't supply that sort of granular information. So being able to, it needs better smarts in the inverter to be able to then start talking to the home energy manager or the home.
I'm saying it would just charge it.
Oh yeah, well, it will just charge it. Yeah, but if you wanted to control what was going on, then that's the difference, and that's where the effect of whether you want to optimise it against the utility of the car, the feed-in tariff you're under, getting off the grid, optimising against greenhouse gases. I mean, those 4 different objectives would lead to different control strategies. So that's part of the challenge, I suppose you could say. But someone will solve it, and it's not that difficult.
With this particular guy, was there anything unique about his situation that made it work? Whereas if you apply this, I haven't read the article.
No, that's sure. It was down to the fact he just had it's very simple, the business case he's got, because all it reflects is he has a very large solar system he had a reasonably large capital outlay on. He had it installed and he had a normal car that he was driving around. I think he actually had quite a nice car, to be perfectly honest. It was a relatively big car. Then he turned the car over to a Volt, and then he basically took into account how much he was saving on running the Volt and how much that input was a reflection of his solar. And so he basically took the cost saving of the Volt into account against the business case of his solar system.
There wasn't any indication whether he had to work certain hours and then the car was at home?
No, the article talks. The article is a very human article. It's not a very technical article. It's about literally, this is what my life is like, and this was the outcome.
Gotcha.
So it's sort of interesting reading. This was only a couple of weeks ago, so
Yeah,
so have a look at that
It's in
one.
a couple of places I've read.
Have you? Yeah. I actually swapped a tweet with the guy because I was interested to know whether he'd considered putting in storage in his home, because we were sort of looking at that a little bit, and he said he ran out of cash. Basically, he dropped about 50 grand on the whole exercise. It was his wife was barely talking to him. So so anyway, yeah. So all interesting stuff. If you would like to look at the report, there's two parts to the report. There's the main report, which is 50 pages, and appendices, which gives you the background to the smart grid and all of the details to do with the charge management scenarios, etc. You can get onto it via that link, and if you've got random thoughts or abuse, then you can send them to me, and I'll field them as they arrive, I suppose. So that's my interest there. So thanks for your time and your interest.
All right, well, thanks a lot, Kristian. That was a really interesting presentation. I'm sure people will have a few more questions for you afterwards if you can hang around for a few minutes.
Yeah.
Okay. To your comment. So, Rebecca, directions?
Yes. So the meeting we've got to